Hello, in this video we are going to finish the Kepler's third law and we are going to see the Newton's law. Now, Kepler's third law, we say is that the mean distance between the planet and the sun cubed is directly proportional to the period of revolution of the planet around the sun, instead squared, not cubed. Because you're going to see that upon proving the Kepler's third law while using the Newton's law of gravitational motion, we are going to see that it's instead cubed for the radius or the distance between the mean distance between the planet and the sun, and we're going to see squared for the period. Now, we should have some points to note on this law which has been stated just now. And the first point and the main point that I want to put in your mind is the mean distance. So my question I'm going to ask everyone is, why did I use the word mean distance between the planet and the sun? The word mean is actually used because if we come back to our initial diagram, we said from the Kepler's first law that the planet is rotating around the sun in an elliptical path. So we realize that as from the ellipse, we see the sun has a certain distance r, let's say r1 here, from the planet to the sun. And now this is second distance which will be here, and this one will be r2. And we see that there will be a third distance here, and this one will be r3. And we see that all distances r1 is not equals to r2, which is not equals to r3. So it implies that the distance between the sun and the planet is quite different all around the ellipse. Now, so this is why the word mean has been used. The mean distance between the planet and the sun. The word mean will come because all the distances that we have seen here behind, R1 and R2, in order for me to find the mean of the distances, what I'm going to do is that I'm going to sum all the distances from R equals to R0 to R infinite number of points in order for me to have the mean distance, Ri. So the distance will start, let's say we start from this point and we are going to rotate all around to this point. And now, since all these points are continuous and not discrete, the summation sign is going to change to an integral sign, as we're going to see in mathematics. So, we know that for me to find a mean, I am going to do R1 plus R2 plus R3 plus R4 plus R2, an infinite number of points, all divided by all the number of points that are added. So, the R mean here will be a summation from R0 to R number of points that I have, all of the value R, all divided by the number of points I have. Now, since we know that all this is an elliptical path, and I need to take from a point here to a point here, what I'm supposed to do, or what further physics does, is that they can do from further mathematics and R, and since they are continuous, there will be an integration from R from a point, or theta equals to 0 to a theta equals to 360 degrees of A cos theta, because this is the formula of an ellipse if you convert it to a polar coordinate. But now, this is not the basis of the physics analysis, and so we are going to leave it for a further mathematics class. Now, so this shows the end of the Kepler's law, and now the point to note here in physics will be a conclusion. The conclusion here will be Kepler's law is mainly based on observations, and Newton's law is mainly based on mathematical equations. Now, we are going to see again that the Kepler's law states that it is mainly based, the planet rotation revolution is mainly based on ellipse, while Newton's law is mainly based on